Greetings, my name is Elizabeth Wade. I teach basic calculus at Pellissippi State Technical Community College for the Mathematics Department. This is Topic 1 on limits and Segment 1.4 on asymptotes. In this segment, we're going to look at the relationship between limits, asymptotes, and infinity. In our first problem, we're asked to find the limit as x approaches 2 of 3x plus 1 over x minus 2. The first thing I would do is try direct substitution, but notice that direct substitution yields 7 in the numerator and 0 in the denominator, a non-zero number divided by 0. Whenever this happens, then this indicates the presence of a vertical asymptote. Let's look at the graph of this function. This is the graph of 3x plus 1 divided by the quantity x minus 2. First, notice that at x equal 2, there is a vertical asymptote. As x approaches 2 from the left side, the graph is moving in this direction, getting infinitely negative. The left-hand limit does not exist because of this behavior, but we can use negative infinity to describe this behavior, and we can write the limit as x approaches 2 from the left, a left-hand limit, of this function f of x is equal to negative infinity. Similarly, as x gets close to 2 or approaches 2 from the right side, the graph is headed in this direction, getting positively large, infinitely large, headed towards positive infinity. And we can write the limit as x approaches 2 from the right side, the right-hand limit of the function f of x is equal to positive infinity. The answer to our problem, the limit as x approaches 2 of 3x plus 1 over x minus 2, in general, the limit does not exist. Let's take another look at this same function, 3x plus 1 over x minus 2, and let's try to find the limit as x approaches infinity or as x approaches negative infinity. Again, let's look at the graph. Notice that as x moves along the x-axis in a positive direction, or as x gets infinitely large, the function is moving in this direction and is actually approaching a height of 3. There is a vertical asymptote, a horizontal asymptote at x equals 3. So this horizontal line I just drew, or broken line, because it's not part of the graph, is a horizontal asymptote, and it's at level 3. And so this graph is closing in on 3, but it never touches that line. This can be shown in a table. I created a table on my calculator using this function, 3x plus 1 over x minus 2, and I put in x values of 10, 100, 1,000, 10,000, 100,000. I was letting x get infinitely large, and I was watching what the y values were doing. And you can see that the y values are getting closer and closer to 3, but they never quite reach 3. In a similar manner, as x moves along the x-axis in a negative direction, moving this way, or as x gets infinitely small, the function again would approach a height of 3, this time from underneath the horizontal asymptote. We state the limit as x approaches negative infinity of 3x plus 1 over x minus 2 is equal to 3. Now the question arises, can we work this problem, the limit as x approaches infinity of this expression, algebraically? To do this, you compare the degree of the numerator with the degree of the denominator of the fraction. In this case, the degree of the numerator, 3x plus 1, is 1, because there's an exponent here of 1. The degree of the denominator is 1. If the degrees are equal, as they are in this case, because they're both equal to 1, then the limit at infinity will be the fraction formed using the coefficient of the term with the highest degree in both the top and the bottom of the function. In our situation, the coefficient of the expression in the numerator would be 3, because this is the term with the highest degree. In the denominator, the coefficient would be 1. And so the limit as x goes to infinity, according to this rule, would be 3 over 1, which is equal to 3. Let's look at another quick example. The limit as x approaches infinity of x squared plus 1 over 2x squared minus 1. Notice that the degree of the numerator and the degree of the denominator are the same. So according to this rule, I take the coefficient of the numerator, the term with the highest degree, which of course is the x squared term, so the coefficient would be 1, and in the denominator, the term with the highest degree, of course, is the x squared term, and the coefficient is 2. So the limit as x approaches infinity would be 1/2. Well, what if the degrees of the numerator and the denominator are not equal? If the degrees are not equal, and the degree of the denominator is higher, and that's the case in this example, the degree of the denominator is 4, the degree of the numerator is 3, then the limit in this case is 0. You can confirm this by looking at the graph of this function. This is the graph of 5x cubed minus 1 divided by the quantity x to the 4th plus 1. As this curve moves to the right, it's closing in on the x-axis. So the x-axis is a horizontal asymptote. And as x gets infinitely small, moving in a negative direction, the graph again approaches the x-axis from below. So the x-axis is the horizontal asymptote, and the limit is 0. Well, what if the degrees are not equal and the degree of the numerator is higher than that of the denominator, as in the case of this example where the degree of the numerator is 2 and the degree of the denominator is 1? In this case, the limit does not exist because it is infinity. You can confirm that by looking at the graph of this function, x squared plus 1 divided by x. Notice that as x gets infinitely large, the graph is headed to positive infinity. And as x moves in a negative direction, the graph is headed to negative infinity. So the answer to both of these would be that the limit does not exist. Well, that is it for this segment. Now you need to practice this concept by working similar problems. Good luck.